Other students. So today I'm going to discuss pH question. To just watch each question discussion and try to understand the concept behind each question. So here let's discuss the first question. pH of water is 7. 7 that means water is neutral. When any substance Y is dissolved in water, then pH becomes 13. The substance Y is a salt of. So here you can notice the pH is 7 and it has become 13. That means pH is increasing. That means the substance which you are adding into the water, making the water solution basic in nature. So basically, if we will add salt, so it will change the pH of water. But which salt? We know that either we can add salt of strong acid and weak base, right? Or we can add salt of salt of weak acid plus strong base. Now, here we know that we have already discussed that strong acid, for an example, HCl and NH4OH, weak base. If we will add NH4Cl, so the pH will decrease. Why? Because NH4 plus ion will hydrolyze water. So how it will hydrolyze water? So NH4 plus, if it will get added to water, it will form NH4OH and it will release H plus ion. So from water, OH minus will get abstracted by NH4 ion, right? So when we have strong acid salts, then solution is acidic. And when we have strong base salt, strong base, for an example, NaOH and weak acid, acidic acid. So here the salt which we will get CH3COO Na, and here CH3COO Na. When we will add this salt, so CH3COO minus will hydrolyze water and it will give acetic acid and it will release OH minus ion. So basically, if we have a salt of strong base and weak acid, the solution, resulting solution will be basic. So here, which option is correct? Strong acid, strong base, that is incorrect option. Weak acid, weak base, incorrect option. Strong acid, weak base, incorrect option. B, weak acid and strong base. The fourth option is the correct one. Now let's solve this question. So in this question, let me flip this here. Uh, Minimum pH is shown by aqueous solution of minimum pH. Please understand that means acidic solution. Minimum pH means acidic solution is shown by aqueous solution of. Now we have to find out that which will hydrolyze the water. Let's talk about BaCl2 first. So here in BaCl2, we have two ions. Which are the two ions? We have Ba dye positive plus 2Cl minus. BaNO3. In BaNO3, we have two ion. Here also Ba dye positive plus 2NO3 minus. And we have BaOH twice. BaOH twice. In this we have Ba dye positive and plus 2OH minus. And the third one which we have is BCl2. And here we have B dye positive plus 2Cl minus. Now notice barium chloride is an alkaline salt made up of alkaline earth metal and this. This is also strong salt. This is base only. BCl2. Here B dye positive has amphoteric nature. So what it will do, B dye positive, it will hydrolyze water. It will withdraw the OH ion from the water and it will release H plus ion in the water. B dye positive, a small size of beryllium. Because of its small size, polarizing power of B dye positive is maximum. And that is why the right answer will be minimum pH is shown by BCl2, not by Ba. Ba, alkaline earth metal. B is also is comes in group 2 as block L. B also comes in group 2, but here because of its amphoteric nature, small size, it will hydrolyze water. And when it will hydrolyze water, here it will release H plus ion, which will decrease the pH. Now, let's solve this next question. So, I'll solve the question right side. Now, read this question here, everyone. So, here it is. Choose the correct statement having same pH. pH means what? Please understand. pH means concentration of H plus ion should be same. pH means concentration of H plus ion. What is the formula of pH? It is minus log molar concentration of H plus ion. Log here it is there in the base 10. Now, if we will notice the concentrations of H plus ion. So basically, please understand, suppose we have 0.05 molar H2SO4, first one option. So here we have H2SO4, where we will add H2SO4 in water. So aqueous solution of H2SO4 will give 2 H plus ion and SO4 di-negative ion. We know that 2H plus ion. That means if we have 1 molar H2SO4, it will give 2 molar H plus ion. Here, what is concentration of H2SO4? It is 0.005 molar. So here 2H plus ion means 2 into 0.005, or we can say the H plus ion concentration is 0.010 molar. So we got 0.10 molar. Similarly, here in D, if you will notice that the concentration of HCl, how HCl will break? HCl will break into H plus and Cl minus. So what is concentration of H plus here? 0.01 molar. What will be the concentration of H plus here? 0.01 molar, and Cl also 0.01 molar. So this two has same concentration of H plus ion. Now let's see this option. Na2SO4, here there is no H plus ion, so this will not have the same pH, right? What is pH of this solution? This solution pH here 10 raised to power minus 2. 10 raised to power minus 2, that means pH is 2, right? Here also, what is concentration of H plus ion? 10 raised to power minus 2, that means pH is 2. This is H plus ion, that means pH is 2. Now, if we will see third option, so here concentration of NaOH is 10 raised to power minus 2. Here we have NaOH. When it will break into Na plus and OH minus. So here 0.01, and here you also 0.01 and 0.01, which is equal to 10 raised to power. This is POH. For this solution, POH is 2. So which is the right answer here? A and D. Which option is correct? A and D. Right, students, so hope you have understood this. Now let's discuss the next question. Next question here. Please understand 66 question number. It is in the following solutions, the concentration of different acids are given, which make up the acid has highest pH. Highest pH is you know that concentration of H plus ion. So please understand, if H plus ion will increase, then pH will decrease. Please understand, H plus ion will increase here, increases, pH decreases. That means H plus ion concentration decreases, pH increases. This is the concept where you have to apply. So basically we have to see that for which of the solution H plus ion concentration is least. For which of the solution H plus ion concentration is least. So let's see that for which of the solution H plus ion concentration is least. So here let's talk about the first one. We have M by T, H2SO4. How this H2SO4 will break? It will break into 2H plus SO4 dinegative. If it is 1 by 10, so it will be 2 by 10. 2 by 10, that means 2 by 10 means 1 by 5. 1 by 5 means 0.2 molar. So here concentration of H plus ion is 0.2 molar, right? Please notice. Similarly, M by 20. M by 20 means 1 by 20. So here 1 by HNO3, please understand. H plus NO3. So here it is 1 by 20. Here also it is 1 by 20. 1 by 20 means what? 1 by 20 means 0.05, right? And M by 10. Again, this one, M by 10, that means 1 by 10. 1 by 10 means HClO4, M by 10, that means 1 by 10. 1 by 10 means 0.1. So what is the H plus ion concentration here? So we can notice here 2, 0.2 plus 0.1, 0.35. So this mixture has total how much concentration? 0.35. So here 0.35 molar. Right, please notice here. Similarly, here 1 by 10, by 1 by 10, 2 by 20. 2 by 20 is, please understand, next option. Let's see the next option. And the next option, let me erase this, everyone. Okay, fine. Now, and the next are M by 20. M by 20 means 2 by 20. Why? Because H2SO4 will give 2. So 2 by 20 means 1 by 10. 1 by 10 means 0.1. M by 10 plus 0.1. M by 20 plus 0.05. Right? So it will give what? 0.25 molar. So here it is 0.25 molar concentration of H plus N. Now see M by 20. M by 20, 2 by 20 again. So M by 20, 2 by 20, 2 by 20, 0.1 plus 0.1 plus M by 40. So 1 by 40. So 0.025. So it will be 0.225. Here 0.225 molar. Concentration of H plus ion is 0.225 molar. Here still M by 20 like 0.1 plus M by 5. M by 5 means 0.1 by 5, 0.2 plus M by 5. Here also 0.2. So it has highest pH 0.5. So if you will notice that which has less concentration of H plus and third one. So the third one is going to be right answer. Right, everyone? So I hope you understood this concept. Now, what was the concept? Which has highest pH? The one which has less concentration of H plus ion. Next question. If 100 ml of pH 3 and 400 ml of pH 3 solutions are mixed, what will be the final pH? Please understand here. Volume, we will have to take 100 ml. pH is 3. pH 3 means concentration of H plus ion is 10 raised to power minus 3. V2 is 400 ml. And here also concentration of H plus ion is 10 raised to power minus 3. There is a concept M1 V1 plus M2 V2 divided by V1 plus V2 equal to M3. When we are mixing two solutions, then the concentration of new solution will be equal to M1 V1 plus M2 V2 plus V1 plus V2. So here M1 V1, what is M1 everyone? Molar concentration 10 raised to power minus 3 into V1, V1 is 100 plus M2 10 raised to power minus 3 into 100 divided by V1 plus V2. V1 is 100 ml, V2 is 400 ml. This is M3. You can take 10 raised to power minus 3 common. So when we will take 10 raised to power minus 3 common here, so 10 raised to power minus 3 will become common. Here 100 plus 400 will become 500. 500 divided by 500 equal to M3. So here 500, 500 will cancel. Here final concentration M3 is 10 raised to power minus 3. This is actually concentration of H plus ion and which will have pH equal to 3. Right? So this concept you have to use here. So what is correct answer for this? This one. Now let's solve the next question. So next question, 10 is to power minus 7. This concept is important, everyone. This question. 10 is to power minus 7 molar HCl is diluted 100 times. The pH is, please understand. So here 10 is to power minus 6, sorry, not minus 6. Suppose I am taking 1 ml, right? And V2 is 100 ml and M2. If we will use this concept, please understand. So here M2, we will get 10 is to power minus 6 divided by 100, right? 10 is to power minus 6 divided by 100, one volume, right? So here 10 is to power 100, it will become 10 is to power minus 8. But actually, please understand, it will become 10 is to power minus 8. And the pH of solution will come 8, which is not possible. Please understand this concept. So pH of this solution cannot be 8. This is important concept. Why? Because pH is basic. So how to solve this question? So for to solve this question, there is a concept which we have to understand that when we have H plus ion concentration 10 is to power minus 6. Remember this H plus is diluted. That means total H plus ion, if we have to consider total H plus ion, that is the sum of 10 is to power minus 6 plus 10 is to power minus 7. Why I am adding here 10 is to power minus 7? Because 10 is to power minus 7 is the concentration of H plus ion which is present in the solution, So when the solution is diluted 100 times, so that solution has H plus ion more. Please understand this 10 is to power minus 6, 10 is to power minus 7. So here, what is the concentration? We can take common, take common 10 is to power minus 6, 1 plus 1 by 10. So here, concentration of H plus ion, which is there, please understand, concentration of H plus ion will be 1.10 into 10 is to power minus 6. Why 1.10 into 10 is to power minus 6? Because it is diluted. Now understand one thing. The pH of this solution will never be more than 7 because it is still acidic. So pH of this solution will be less than 7 and closer to 7. That is 6.95. That is 6.95. Now technically, if we have to solve this question, so here we got H plus ion. Please understand how we got. Let's have a numerical approach. Okay, conceptually we have understood that pH cannot be acidic solution. pH cannot be more than 7. It will be less than 7. So we got H plus ion here according to the concept 10 is to power minus 8 molar, right? But total H plus will not be 10 is to power minus. Total H plus, please understand, will be equal to 10 is to power minus 8, 10 is to power minus 8 plus 10 is to power minus 7. So here we can take common 10 is to power minus 7. So it will become 1 plus 1 by 10. Please understand total H plus. So here total H plus has become 1.1001 1.10 total H plus 1.10 into 10 is to power minus 7. This is after dilution. Before dilution, it was 1.10 into 10 is to power minus 6. After dilution, this. And now if you will find pH of this, so minus log 1.10 into 10 is to power minus 7 using this formula. Please understand pH will come here minus log 1.10 minus log 1.10. Please understand everyone. pH for this will be minus log 1.10 and plus 7. We know that minus log 1.10 will have some value. So it has a value approximately 0.05 minus 0.05 plus 7. So it will come 6.95. That is how theoretically we can calculate. Please understand. This was the concentration of H plus ion, right, after dilution. After dilution, this is concentration of H plus ion after dilution. This is a contribution of H plus ion from water because it is diluted. So in water also there is 10 raised to power minus 7. When you have to consider water concentration, when H plus concentration is nearly equal to water concentration or less than the water concentration, right? So this concept we have to use. I hope you have understood this important concept. Let's solve the next question. Here in the next question, pH of 0.01 molar acetic acid would be. Now understand, acetic acid is a weak acid. Acetic acid is weak acid and pH of acetic acid depends upon degree of dissociation. So if I will talk about acetic acid, it's a weak electrolyte. It will not dissociate completely in water, right? So here, if I'm considering it has a C concentration, and here C concentration and alpha is degree of dissociation. So here pH will be equal to, here H plus will be equal to concentration into alpha. If alpha is 100%, if alpha is 100%, that means it will become strong electrolyte. Then H plus will be equal to C. But actually H plus will not be equal to C. Here, what is the concentration of acetic acid? C is given 0.001. That means 10 raised to power minus 3. That means equal to 3. pH equal to 3. Right. So here pH is equal to 3. That means it is acidic. When it is acidic, when it is strong electrolyte completely. But however, pH will not be 3. It will be less acidic than 3. So pH will always be greater than 3 in case of this because H plus ion will not release completely into the aqueous solution. That means if more H plus, less pH, less H plus, more pH. So here, if it is 100%, then pH is 3. But it is not 100%, that means H plus is less, pH will be more. Right? So I hope you have understood these concepts too. Now let's solve the next question. Here in this question, it is given pH of solution is increased from 3 to 6. Its H plus concentration will be. So basically, let's talk about if we have pH 3, that means what is concentration of H plus ion? Here 10 raised to power minus 3. Please understand. And if we have pH 6, that means concentration of H plus ion is 10 raised to power minus 6. How much increase or decrease is there? Right? We can take the ratio also. Suppose here 10 raised to power minus 3 divided by 10 raised to power minus 6. It will become 10 raised to power minus 3 into 10 raised to power 6 or 10 raised to power 3. Right? So how much time it has got increased? How much time it has got increased? 1,000 times. How much time it has increased? 1,000 times. Right? Understand? 1,000 times. Because this is H plus 1 divided by H plus concentration. Second concentration. Understand this question somewhat tricky also. How tricky? Because with respect to what we are talking, if pH has got increased 1,000 times, then H plus concentration has got reduced 1,000 times. Understand this? So basically, here we have, let's consider H plus 1 is equal to 10 raised to power minus 3 and H plus 2 for second concentration is equal to 10 raised to power minus 6. Now see the ratio of these two is concentration H plus 1 divided by concentration of H plus 2. it is equal to 10 raised to power minus 3 divided by 10 raised to power minus 6. Right? Final, how final is related with initial? That is important. So invert this. If you will invert this, it will become h plus 2 divided by h plus 1. That is equal to 10 raised to power minus 6 divided by 10 raised to power minus 3. So if you will invert it, final concentration, this is final concentration is equal to 10 raised to power minus 3 into h plus 1. The final concentration is h plus 1 divided by 1000. Right? Final concentration has got reduced by how many times? From its initial 1000 times. Right? From initial concentration, final concentration has got reduced by 1000 times. Got it, everyone? So this is a way. Another way also we can find the difference of this initial and final. So here if we have final H2 H plus 1 10 raised to power minus 6 minus 10 raised to power minus 3. So we can then also we get that same answer. Okay, so this is an important concept in the ratio form. It will be more easy to relate to things. It will be more easy to relate to things. Right? Long for this is reduced by 1000 time. Reduced by 1000 time. Less concentration. Next question, everyone. A solution has pH equal to 13. The solution will be POH. So we know that POH relation, right? I hope that pH is equal to pKw is equal to pH plus POH. pKw is equal to pH plus POH. So here we will write pKw equal to pH plus POH. So simply here POH is 30. So pKw is 40. pH minus 30. So pH will be 1. So basically pOH is 13. So solution will be highly acidic or highly basic. So plus, sorry, pH, pH plus 30. So 30 minus. So here pH is 1. Now tell me, solution is highly acidic or basic? When pH is 1, the solution is highly acidic. Solution is highly acidic. Got it? Next question, everyone. So we have a list of questions. So let's solve next questions too. So the pH of solution containing 10 ml of 0.1 molar NaOH and 10 ml of 0.05 molar H2SO4. Please understand this concept is based on the reaction here. So we have acid and base solution. We have acid plus base. When acid base react, it forms salt. Salt plus water. So let's directly write down that reaction so that we can understand. Here, which base we have? We have NaOH4 and we have H2SO4. When we have H2SO4, when it is mixed with NaOH, we know that 1 mole of H2SO4 requires 2 mole of. It forms Na2SO4. Now, 1 mole require 2 mole. It is very simple calculation. So, if we will consider here the balanced chemical equation, here 0.05 mole is there. And here how many mole is there? 0.1. So you can see that 0.05 and 1. So if it is 1 mole required 2 moles, so here 0.05 mole will require 0.1 mole twice. So pH will be, this solution is neutral. This solution is what? Neutral, because acid and moles are reacting together to form salt. Right? So pH of this solution will be equal to 7. Right? So here volume is also 10 ml. If volume is changed, then also things will change. 10 ml. Please understand. Next question. In a solution of pH 5, here, in a solution of pH 5, more acid is added in order to reduce the pH up to 2. The increase in hydrogen ion concentration is. So we know that pH is 10 is to pH is 5. That means H plus ion is 10 is to power minus 5. And here pH has become 2. That means concentration of H plus ion has become 10 is to power minus 2. So 10 is to power minus 2. This is H1 and this is H2. Ratio we will take H2 upon H1. Directly I am taking. So here it will come 10 is to power 3. 10 is to power 3 times. The final concentration has be, increased by 1000 times than the initial concentration. Right? So this is simple question, 1000 times. Next question. The hydroxyl ion concentration in a given solution is this. Its pH will be OH concentration. Sorry, the hydrogen ion concentration. Here it is given. The hydrogen ion concentration in a solution is 6 into 10 to the power minus 4. So its pH will be. So here it is given H plus ion concentration. Simple, it is 6 into 10 to the power minus 4. We have to take log. So for pH, pH is equal to minus log concentration of H plus ion. Here concentration is minus log 6 into 10 to the power minus 4. Right? Minus log 6 plus 4. We know how to solve that. Log 6 has value 0. Log 6 has 0.7. 9 something plus 4 minus. So 3.22 it will come around. So the right answer is 3.22. Right, everyone? Next question, 76 question number. Let's solve next question. 76 question number. So in 76 question number, the pH of solution is 10. pOH is given 10. That means what is OH ion concentration here? OH ion concentration is 10 to the power minus 10. Then hydrogen ion concentration. We know that in formula pH plus pOH is equal to pKw, and we know that pH is equal to pKw minus pOH. pKw is 14 minus 10, it is 4. Right. In this way, the answer is not given pH, but H plus ion concentration. If pH is 4, then H plus ion concentration will be 10 to the power minus 4. Right. So here 10 to the power minus 4. That is one answer. But here they have given many answers. So now in the second way, let's see the second way also. We know the formula Kw is equal to H plus ionic product of water. Kw is equal to H plus ion and OH minus ion. 10 is to power minus 14. Let's not write the Kw value, not the given in the option like value. So here H plus ion is equal to Kw divided by OH ion concentration. So this is also a correct answer. B and D is the correct. Let's talk about this. So that is not the correct answer. The hydroxide ion concentration is, so B and D, H plus ion. Okay. One more option has to be given. Since it is not given, this is for OH ion concentration, so this cannot be answer. This can be an answer. No, how this can be an answer? Kw upon 10 is to power minus A. This cannot be an answer, and this can be answer. So right option for this will be no. Right? Now let's see the next question. Why this cannot be answered? Because here H plus will be equal to Kw upon concentration of OH minus N. And OH minus N is given 10. Next question. An aqueous solution whose pH is 0. pH 0 is acidic solution. pH 0 is lowest pH acidic solution. Next question. Everyone, let's solve next question. Following 5 solution of KOH were prepared as first 0.1 mole in 1 liter, 0.2. The pH of resultant solution will be. So here you have to find concentration of OH minus ion, and you have to add all the OH minus ion. You have to find POH first. So here let's find out total concentration of OH minus. So 0.1 divided by 1 plus 0.2 divided by 2 plus 0.3 divided by 3 plus 0.4 divided by 4 and 0. So here you can find it is 0.1 plus 0.1 plus 0.1 plus 0.1 plus 0.1. 1, 2, 3, 4, 5. So 0.1, 0.5 H plus concentration is 5 into 10 raised to power minus 1 OH concentration. Please understand. Then POH will be pi log 5 plus 1. Please understand. Log 5 as well is 0.0. So approximately the pH of resultant solution will be 13. Considering that, because not given the value, so it will be approximately 13. Next question, 79 question number. Let's solve this 79 question number, everyone. So we have more questions as well. Let's solve this 79 question number. pH of 0.2 molar ammonia solution which has 5% ionization. Now we have ammonia. Let's consider this ammonia. Ammonia, when we will add ammonia in water, it will ionize water, right? It will abstract proton from water. It will form this and OH minus. Now the concentration of this is 0.02 and alpha is given. So if you will write this equation, if you remember that C minus C alpha, here will become C alpha. So what is concentration of OH minus here? It will be C into alpha. And concentration is given 0.02. Alpha is given 5%. That means 5 by 100. So 0.05. So 0.02 into 0.05. So 2 tens. So 0.0010. Right. Or so here, please multiply this 0.02 and 0.05. It will become 0.0001. Right. Now, right. So if I have 2 into 5, it will become 10 into 10 raised to power minus 4. So 0.001. It's not 4 time, it is 0.001 molar. So POH will be 3. So pH will be 11. So this answer is 11. So in this video, we will stop here, everyone. I hope you have understood the concept. In the next video, if I will record the next video, I will continue the remaining question. Thank you for watching this.